Even before considering issues like mass of shielding required for nuclear rockets, however, the high specific energy of nuclear fuel is a major advantage for high energy missions. Now come to the nozzle assembly. What kind of nozzles we will look forward for this kind of engine. The design of an appropriate nozzle for these kind of nuclear thermal rockets will not differ significantly from the nozzles which we are using in our present technology. The traditional convergent diversion nozzle can be used to accelerate flow to supersonic exit velocity. Extension ratio, which the chemical engine gives us, is around 18, but nuclear powered ramjets can give a nuclear powered engine can give us extension ratios of about 300. So this way we can achieve the thrust to maximum closer to the theoretical maximum, and this will contribute to an increase in exhaust velocity. Now the most problematic part is the reactor core, because sometimes we think that we need a quite huge reactor for making it critical, uranium-235. So I studied regarding that, and I came to know that if we will use pure uranium-235, then reactors can become critical at a radius of 3.4 centimeters. The volume of this cylinder is just 264 centimeter cube. And a reactor, but the problem is real reactor will not use pure uranium. Therefore, the main issue in deciding the reactor core size are likely to be related to the availability of enriched uranium and engineering challenges rather than the energy content. This necessity, this radiation sheet, this is the uttermost necessity which we will look for saving our crew, for saving our people around the world who are below, inside the periphery of flying that rocket or missile, whatever we are flying that. The necessity of the construction of an effective radiation shield between the engine and the two compartments. For neutron accretion, light materials such as lithium hydride can be used. For gamma rays, however, a dense material such as tungsten can be used. The radiation shield tends to be a major investment of mass and may not be necessary in cargo-like applications. Although radiation shields are necessary between the propulsion systems and two compartments, a major significant radiation problem is created by cosmic rays. But these cosmic rays are produced by our normal ramjets also. Therefore, even a chemical system will need to shield missions of any appreciable length. Now come to the heat exchanger part. This is the most critical part of a ramjet engine, because what we are doing is we will supply heat through this heat exchanger into the combustion chamber of a ramjet or a scramjet engine. Improved performance of the nuclear engine in terms of exhaust velocity is solely on the raising the temperature of the heat exchangers. There is more than adequate power available, but the only problem is with the heat exchangers. We need to design the heat exchangers which can supply a tremendous amount of heat to the flowing propellant, so that we can generate the useful thrust or the desired thrust. Heat from the heat exchangers is carried away the propellant, and graphite is the highest thermal conductivity, so we can use graphite for manufacturing our heat exchangers. But we can for some better options also based on some nanotechnology. In this diagram, I tried to show the principle on which some of the nuclear thermal rockets were tested in between 1915 to 1970. There was a